Ever catch yourself wondering if AI could actually be, creative?
Creative.
Yeah, and I don't just mean rearranging what's already out there. I'm talking about coming up with genuinely new scientific discoveries. Like, could AI be the next Einstein?
It's a question that's been on everyone's mind lately, right?
Right, totally. And thankfully, some researchers decided to tackle it head on.
They even wrote a whole paper on it.
Catchy title, too. Ready for this. Can large language models unlock novel scientific research ideas?
Straight to the point. But how do you even begin to test something like that?
Well, for starters, they didn't just throw any old data at these AIs.
Tell me they didn't just use Wikipedia?
Oh, absolutely not. These researchers were way more clever than that.
So what did they use?
They took a bunch of recent scientific papers published after 2022.
After 2022. Why so specific?
Think about it. Using papers published after 2022 minimizes the chances of the AI just spitting back something it's already seen during its training.
Like making sure your study buddy isn't just quoting the textbook back to you.
Exactly. But get this, it gets even more interesting. They actually removed the future work sections from those papers.
Wait, why would they do that? Those sections are like gold mines for new research ideas.
Exactly. That's the whole point. They wanted to see if the AIs could come up with those future work ideas independently, without peeking at the answer key.
So it's like a true test of originality then.
You got it. The AI has to come up with its own ideas blind to what the researchers already had in mind.
Okay, so they've set the stage. No cheating allowed. Now, which AI contestants are we talking about here?
Oh, we've got a lineup of some real heavy hitters in the world of large language models. We're talking Gemini, Claude 2,
Claude 2, interesting.
GPT 3.5, and of course the one everyone's talking about, GPT 4. Each one was put to the test, tasked with generating fresh research ideas based on these pre-2022 papers.
This is getting good. I'm ready to crown a winner.
Hold your horses. We've got the contenders. We've got the challenge. But how do you actually judge the creativity of an AI? I mean, how do you quantify something like that?
That is the million-dollar question.
So last time, we left off with our AI contestants all prepped and ready to wow us with their research prowess.
Raring to go.
But, it got me thinking, how do you even begin to judge something as abstract as creativity, especially when it comes from an AI? It's not like we can just ask them, so how original are you feeling today?
It's a tricky one, right?
Totally. Luckily, the researchers behind this study, they're way ahead of us.
They always are.
They actually came up with not one, but two different metrics specifically for assessing the AI-generated ideas.
2. Give me the deets.
Okay, so the first one they're calling the Idea Alignment Score, or IAScore for short. And this is where that whole removing the future work section gets really interesting.
Right, like hiding the answer key, keeping things honest.
Exactly. The IAScore basically measures how closely the AI's ideas align with the research directions that the original authors actually proposed in those hidden sections.
So it's not enough for the AI to just spit out any random idea. It has to come up with something that aligns with what the human experts in the field were already thinking.
You got it. But hold on, because a high IAScore, it's not the whole story. What if the AI just comes up with like 10 slightly different versions of the same idea? We want diversity of thought, right? We don't just want the same song on repeat.
We want a whole mixtape of groundbreaking research.
Exactly, a mixtape for science. So that's where the second metric comes in.
Hit me.
This one is called the Idea Distinctness Index. Catchy, right? It basically assesses how different and diverse the AI's ideas are from each other. Are they exploring truly unique paths, or are they just rehashing the same old concepts?
So it's a two-pronged approach to judging AI creativity. IAScore checks for alignment with, like, expert-level thinking, and the Distinctness Index makes sure we're getting a variety of ideas, not just the same idea with a new hat on.
You've got it. It's all about that originality. So with our judging criteria set, how did our AI contestants actually do? Were any of them able to truly impress?
Drum roll, please. The results were pretty eye-opening. Turns out not all AIs are created equal in the creativity department.
You're killing me. Just tell us who came out on top.
Well, the clear frontrunners were Claude 2 and GPT 4. They consistently blew the competition out of the water, scoring significantly higher on both the IAScore and that Distinctness Index.
So the newer, more advanced models, they kind of stole the show.
They definitely took the lead.
But we're talking about AI generating ideas on par with, if not better than, human researchers. That's a high bar. Just how much better were Claude 2 and GPT-4?
Get this. In some cases, Claude 2 actually outperformed the human researchers on the Distinctness Index.
Wait, seriously. And AI came up with a wider range of unique research ideas than the actual scientists.
Yeah.
That's wild. But even with those impressive scores, we've got to ask ourselves, are these AI-generated ideas any good in the real world? I mean, could they actually lead to new scientific discoveries, or are they just fancy-sounding nonsense?
That is the million-dollar question.
Okay, so we've got these AI models, Claude 2 and GPT-4, racking up impressive scores on the creativity scale.
Really exceeding expectations.
But it still begs the question, are these AI-generated ideas any good in practice? Like, could they actually lead to, real-world scientific breakthroughs?
Right, because at the end of the day, it's not just about sounding impressive, it's about moving science forward.
Exactly. So how do we separate the truly groundbreaking AI ideas from the ones that just sound good on paper?
Well, the researchers knew they needed to bring in the big guns for this actual human experts.
Oh, so like a panel of judges for these AI-generated research proposals.
Pretty much. They gathered experts from each of those 5 scientific fields, computer science, physics, the drill.
Right, covering all the bases.
And they gave these experts a selection of research ideas.
Generated by both the AI and human researchers, I'm guessing.
You got it. But here's the kicker. They didn't tell the experts which ideas came from where.
Oh, that's brilliant. A true blind taste test for scientific innovation. So what were the judges looking for? How do you even begin to evaluate the quality of a research idea, AI-generated or otherwise?
They kept it pretty straightforward, actually, focusing on 3 key criteria: relevance, novelty, and feasibility.
Okay, break those down for me.
Sure. So relevance, that just means the idea actually makes sense in the context of the research. Like, you don't want to propose studying black holes in a paper about, say, the human brain.
Yeah, gotta stay on topic.
Exactly. Novelty, well, that's pretty self-explanatory. This is a genuinely new idea. And finally, feasibility. Can this idea actually be researched with the tools and knowledge we have available today?
So it's not just about being creative, it's about proposing ideas that are actually, doable.
Exactly. It's about pushing the boundaries of science, but not into the realm of science fiction.
Love it. So what was the verdict? Did these AI-generated ideas pass the test?
Well, it was a mixed bag, to be honest. Some of the AI ideas, they were a bit obvious or maybe not very practical.
Yeah, you figure there's got to be a few duds in the mix.
Right. And this is the exciting part. A good chunk of the AI-generated ideas, they were actually really promising.
No way. The human experts were genuinely impressed.
They were. They found a significant number of the AI's research directions to be relevant, novel, and, get this, feasible.
Wow. So while they might not be winning Nobel Prizes just yet, these AIs are definitely showing some serious creative chops.
Absolutely. And for me, that's the most exciting takeaway from this whole study. These AI models, they're not just mimicking human thought. They're actually capable of generating genuinely new and potentially groundbreaking scientific ideas.
It really makes you think about the future of scientific research, doesn't it?
It does. Imagine a world where AI isn't replacing scientists, but working alongside them, pushing the boundaries of what's possible.
Like AI could be that extra brain in the lab, helping researchers see connections they might have missed or explore avenues they hadn't even considered.
Exactly. And, there was one other interesting tidbit from the research that really got me thinking.
Oh, lay it on me.
So the researchers, they experimented with giving the AIs different amounts of background information, like context for their brainstorming.
Okay, makes sense. More information should lead to better ideas, right?
Well, that's what you'd think. But here's the thing. That's not always what they found.
Wait, really? More information actually backfired?
In some cases, yeah. The AIs actually came up with more novel and unexpected ideas when they were given less information to work with.
Whoa! That is wild. So you're telling me sometimes knowing too much can actually stifle creativity?
That's what the research suggests. It's like sometimes having access to all that existing knowledge can box us in, make it harder to think outside the box,
That is so interesting. It really makes you think, in a world that's obsessed with information overload, maybe the key to unlocking truly groundbreaking discoveries is actually knowing a little less.
Maybe what we need is a little more of that childlike wonder, that ability to look at the world with fresh eyes, unburdened by everything we think we already know.
I love that. And you know what? I think that's the perfect note to end on. To all our listeners out there, thanks for joining us on this deep dive into the world of AI and scientific creativity. Keep those minds curious, and remember, sometimes the greatest discoveries come from asking the questions nobody else has thought to ask. Until next time. Ever get frustrated with those AI chatbots? You know, the ones that seem to forget what you just said 2 seconds ago.
Like they have goldfish memories.
Exactly. It's like the entire conversation just disappears.
Yep.
Well, luckily for all of us, today we're diving into some brand new research
Cutting edge stuff.
that's tackling this exact problem head on.
It's a game changer.
So let's get right into it. We're talking about gated slot attention,
Or GSA for short.
which is making AI smarter, not just bigger.
That's the goal.
Okay, I am totally on board with that. But before we get into the nuts and bolts of how it actually works, maybe you can give us a little refresher on how these language models even function in the first place.
Sure. Think of a language model like a prediction engine.
Okay.
But it's super powered, right? It analyzes tons and tons of text data
Mountains of it.
to learn all the patterns in language, how we actually write and speak.
So then it can guess what words should come next in a sentence.
Yeah, or how to answer your questions in a way that makes sense.
Right, like when you're typing an email and your phone tries to finish your sentences for you.
Exactly. Except these models, they're doing it on a way bigger scale.
Next level stuff.
Now, a lot of the popular models out there right now, the ones everyone's talking about, they use this thing called a transformer architecture.
Transformer, okay, got it.
And these transformers, they often work with what we call unbounded memory.
Unbounded memory, so they remember everything.
That's the idea. But imagine if you had to carry around every single thing you've ever learned or experienced. You'd be totally overwhelmed.
My brain's already overloaded, and I don't even have unbounded memory.
Right. And it's the same for these models. Unbounded memory, it can make them really expensive to run.
Because they need so much processing power.
Exactly. And it can slow them down, too.
So even AI can get bogged down with too much information?
Exactly. And that's where GSA comes in.
Our hero.
Instead of trying to remember absolutely everything, GSA uses bounded memory.
Bounded memory. Okay, so what does that even mean?
Think of it like this. Imagine you have a backpack, right?
Okay.
But it's got a set number of compartments.
Right.
You can't just stuff anything you want in there.
Gotta be picky.
You got to be strategic about what you choose to pack, the essentials.
So instead of trying to cram everything in, it's more about choosing what's really important.
Exactly. And that's what GSA does. It has a fixed number of slots to store information.
Slots, like a mental filing cabinet or something.
Yeah, exactly. It can quickly stash away the most important parts of a conversation.
Without getting bogged down by all the extra noise.
Precisely.
Okay, I'm liking this so far, but how does it choose what goes in those slots?
It can't just be random, right?
Yeah, there's gotta be some method to the madness.
There is. GSA uses a two-stage process.
2 stages. Okay, lay it on me.
So first, it does a quick scan of all the information, like when you're skimming a book chapter.
Just looking for the key points. Got it.
Right. Then, in the second stage, it takes those selected parts and carefully stores them in its slots.
It's like speed reading with a purpose.
Exactly.
I love it. So it's not just about having limited memory. It's about using that memory in a really smart way.
Exactly.
This feels like a huge change from those older models that just kept piling on more and more data.
And a whole new philosophy.
It's like it's actually thinking about what it needs to remember instead of just hoarding information.
Exactly. It's much closer to how our own brains work, when you say.
Totally. I can barely remember what I did yesterday, let alone every single thing I've ever learned.
Exactly. Our brains are amazing at filtering information, figuring out what's important, what we need to hold on to.
And what we can just let go of.
Exactly. And GSA has something similar built in. It's called a gating system. And it basically helps the model decide what to remember and what to forget.
Like a bouncer for your brain, only the most important stuff gets in.
That's a great way to put it. And this is another thing that makes GSA different. A lot of those older models, those linear models, they weren't so good at the whole forgetting thing. Yeah, they would just keep stuffing information into those limited slots, even if it wasn't that important.
So it's like cramming for an exam. You might memorize a bunch of stuff, but you're not really understanding it.
Exactly. GSA, on the other hand, it's constantly updating its knowledge base.
So it's learning as it goes.
Yeah, it's figuring out what's important in the long run,
I like that.
not just what's right in front of it.
Makes sense. Okay, so I have to ask, there was this one part in the research paper, something about softmax. I'll be honest, I didn't totally get it.
Softmax.
Yeah, it sounded kind of technical.
It is a bit technical, but it's actually a pretty cool concept. Basically, softmax helps GSA speak the same language as those big pre-trained language models,
Yeah.
like BERT or GPT-3.
Hold on. So even though GSA is using this whole new approach with the bounded memory and the slots, it can still learn from those massive models.
Exactly. It's like softmax is a universal translator.
Okay.
It lets GSA tap into all that knowledge that's already out there, even though those models were built totally differently.
So it's like giving GSA a crash course in how to understand language by using all that existing information.
Exactly.
That's incredible. But let's get real. Does this actually work in practice?
Oh, it definitely works.
Is it?
All right, so the researchers, they put GSA to the test, give it all sorts of tasks that require a lot of memory and understanding.
Like what? Give me an example.
Okay, like question answering, where the model has to go through tons of text to find the right answer.
Sounds challenging.
It is, and GSA aced it. Yeah, it consistently did better than a lot of its rivals, especially on those tasks with really long pieces of text.
So that efficient memory usage really gives it an edge.
It makes a big difference.
I mean, just imagine the possibilities here. If we can make AI this much more efficient.
It really opens up a lot of doors.
Right, because right now it feels like these really advanced language models are kind of stuck in the labs.
Yeah, it's mainly just the big tech companies that can really use them.
With all their resources.
Exactly. They've got the computing power, the money.
But if we have GSA, suddenly we could be talking about really smart AI that anyone can use.
On everyday devices even.
It's like instead of needing a giant supercomputer, you've got this like nimble AI assistant right in your pocket.
Exactly, and it can learn and grow just as effectively.
Yeah. Mind-blowing. This is huge. But I'm curious, what could this mean for other fields? Not just better chatbots. What kind of impact could this have?
Oh, wow. I mean, the applications are massive. Think about personalized education, like truly tailored to each student.
Because it can actually process and remember each student's individual needs.
Precisely. Or how about early disease detection? Systems that could analyze really complex medical data.
And make decisions in real time.
Without needing a whole team of experts to weigh in.
And just to be clear, we're talking about doing all of this without those huge energy-guzzling data centers.
Exactly. This isn't just about making AI smarter. It's about making it more sustainable.
More accessible for everyone.
Exactly.
I love it. This has been an incredible deep dive. I feel like we've gone so in-depth.
And we've only just scratched the surface, really. There's so much more to explore.
It's true. This field is moving so fast.
At lightning speed.
Which is exciting, but also, a little bit intimidating.
Okay.
So to our listeners out there, if your brains are buzzing as much as ours are after this conversation, we want to hear from you. What possibilities did this spark for you? Head over to social media, let us know your thoughts, because this is a conversation that's just getting started.
Definitely. There's a whole future of AI out there waiting to be discovered. All right, ready to dive in today. We're tackling AI role-playing. And get this, we're talking about using AI to judge how well other AI can actually, play their parts.
It really is a fascinating new area because it goes way beyond just asking, can AI do this? And moves into, okay, but how well can AI do this? And even how do we measure that? Especially with this new wave of AI like we've seen with ChatGPT.
It's true. We have these really complex AIs now that can chat with us, write poems, even code. But how do we know how good they are when it comes to sticking to a specific role, like in a game or a simulation? That's what this paper we're looking at today is trying to figure out. It's called Ping Pong, a benchmark for role-playing language models with user emulation and multi-model evaluation.
And it's about more than just making chatbots more fun. I mean, that is a plus. But think about the potential here. Imagine AI role-playing, but for serious applications like job interview training, language learning, or even therapy. But to make those scenarios really work, we've got to figure out a way to really measure how well that AI is actually performing in that role.
So the stakes are high then. So their solution, this ping pong benchmark, it makes me think of a constant, back and forth volley, like ping pong match, right? Is that where the name comes from?
Exactly. It's a dynamic evaluation. So it's not like the AI is just answering a list of questions. It's interacting, and it's constantly being assessed on whether or not it can actually stay in character.
Interesting. So how did they actually build this ping pong system? They talk about different AI roles, right?
Yeah, 3 of them, actually. First up, you've got the player AI, which is given a persona. So that means a specific set of character traits, a background, maybe even a certain way of speaking. And they have to actually embody that role, like throughout the entire conversation.
So kind of like if we think of this as a play, the player is the actor who has to really bring the character to life.
Exactly. And to make it even more challenging, you've got the interrogator AI. This one is like the chat partner. So they're there to engage the player in conversation. Usually the interrogator has like a goal or a specific scenario in mind.
So the interrogator is there to really challenge the player and make sure they're thinking on their feet. But then who judges this whole AI performance?
Well, that's where it gets even more interesting, right? Because they bring in a third AI, which is the judge. And this AI looks at the whole conversation, analyzes it. How well did the player AI maintain that role? How engaging were they? Was their language fluent? It judges it all.
Wow, so it's literally AI judging AI. But how do we know these AI judges are any good? Did the researchers test that out?
Oh, they did. And the way they did it is fascinating. They actually had humans judge the exact same AI conversations.
Okay, so they had humans kind of like as a control group almost.
Yeah. So the human judges were rating these player AIs on the same criteria as the AI judges. Like imagine having professional critics, but they're comparing notes with these AI judges.
And what was the verdict? Did the AI judges line up with what the human judges thought?
Well, pretty much, actually. They found a really strong correlation between how the humans scored the AIs and how the AI judges scored the AIs.
Really?
Yeah. It wasn't a perfect match, but it was definitely promising, like enough to suggest that, yeah, we really could use AI to evaluate other AI in a way that's actually meaningful.
That's kind of wild.
Yeah.
But how do we know these AI judges aren't just, spitting out what they've already seen before?
Yeah.
Like if they're trained on like a data set of conversations, couldn't they just be recognizing patterns instead of actually like judging the AI's performance?
That's such an important point, and it gets to a really key challenge with AI bias. Like, how do you avoid bias? So to tackle this, the researchers did something really smart. Instead of just using one AI judge, they decided, let's bring in a whole panel of AI judges.
Wait, so instead of just one AI judge, they had multiple AIs all weighing in on the same performance.
You got it. Like, think about it, right? It's kind of like having a jury in a courtroom. You don't want just one person making a decision in a case as important as that. Each AI model might have its own, strengths and weaknesses.
Right.
Its own perspective. So by combining all those scores from these different models, what you get is a much more kind of well-rounded evaluation.
So it's like getting a second opinion or a third opinion or a fourth opinion, but from AI judges to make sure that evaluation is as fair and as accurate as possible.
Exactly. And that multi-model approach, it's super important when you think about all the ways AI role-playing could be used, right? Like imagine if you're being trained for a really, really important job interview and it's an AI that's training you. You really want to know the feedback you're getting is reliable, that it's objective. And this multi-judge system makes that much more likely.
That makes a ton of sense. So we've gone pretty deep on the mechanics of this whole AI judging AI thing. But let's zoom out for a second. Why should any of this matter to someone who isn't building the next generation of AI? Why should this be relevant to them?
It's a great question. And I think it's important to connect this research back to the real world. This is just a glimpse into the future of AI. It's changing so fast, and it's becoming a bigger part of our lives all the time. And as we start to depend on AI for more and more things, being able to measure how well it's doing becomes really, really crucial.
Yeah. It's like we're putting AI in the driver's seat in some situations, and we need to be really sure it can handle the wheel.
Exactly. This isn't just about, making AI more fun or engaging. This is about situations where AI could be educating our kids or providing therapy or even helping us make really big life decisions. This research is what's laying the groundwork for a future where we can actually trust AI to handle those really complex roles.
It's not even just about if AI can do something. It's about how well AI can do it and how we can know for sure that it's actually doing it right.
That's exactly it. And this study is a really powerful reminder. As AI gets more advanced, so do the methods that we need to use to actually evaluate it to understand its impact.
Yeah. This has been a really interesting deep dive so far. Okay, so we know now we can use AI to judge other AI. And we know that having multiple AI judges makes the process much more reliable. But where do we go from here? It's almost like we're holding up a mirror to intelligence itself when we talk about AI judging AI. Makes you think, right? Like if an AI can tell if another AI is say, giving a really convincing performance, does that mean that AI actually understands something about what intelligence really is?
That's the question, isn't it? It's a huge question. And you know what? It's one that researchers, philosophers, all of us really, we're all going to be wrestling with that for a really long time, I think. But, it's this kind of questioning, this pushing the limits of what we know about AI. That's what makes it so exciting, I think.
It does feel like we're right on the edge of something totally new, something with so much potential, but also, we just don't know what it holds yet.
Exactly. Yeah. And having tools like this ping pong benchmark that we've been talking about today, that's what lets us explore a little more confidently, right? Because we can't forget, this isn't just about, creating AI just to create it. It's about understanding the impact that it has and then making sure that it's actually used responsibly.
This whole conversation has really shifted how I think about AI. It's one thing to talk about it writing a poem or composing some music, but then when you really think about it being developed and evaluated for things like education or therapy, even these really important life decisions, that's a whole different thing.
It is. It really is. And I think this research really highlights why that's so important. Because it gives us this ability, right, to actually assess AI, to guide how it's developed in a way we just couldn't do before.
Yeah, it feels like we're on the edge of something huge. So before we wrap up this deep dive, is there one big takeaway, one big thought that you really want to leave our listeners with?
That's a good question. Okay, how about this? If we're already at a point where we can use AI to evaluate other AI, is it so crazy to think that someday we might use similar approaches to actually measure how humans are performing too?
Whoa.
Right. Like imagine AI not just being a tool that helps us, but actually giving us feedback, helping us learn and grow in ways that honestly we haven't even thought of yet.
Now, that is something to think about. It's exciting and also a little bit daunting, which honestly seems to be a bit of a theme when we talk about AI in the future.
It really does, doesn't it? And who knows, maybe the next time we do one of these deep dives, we'll be looking at the research that today's conversation inspired.
I can't wait. Well, sadly, that's all the time we have for today's deep dive into the world of AI. Thank you so much for joining us on this journey. And until next time, remember to keep asking questions and keep exploring.